Okay, so this is the question we are going to use to understand that particular concept very well. Express vector AB equals 4, 3 in magnitude varying form. Okay, so the first thing to do is to get the Cartesian form of this. Alright, so represent this on the Cartesian plane. Okay, so we have vector AB to be 4, 3. Okay, now representing this on the Cartesian plane is going to be like that. And we know this is the y-axis and that the x-axis. We know this is the x-coordinate and that is the y-coordinate. If that is the case, the 4 here is positive, so it simply means that it goes to the positive side of the x-axis. Okay, so then this is going to be what? 4. And then on the y-axis we have the what? The positive side of y, because it is what? Positive 3. So then this is going to be 3. So it means it is going to be in that quadrant. Now we make a triangle with the x-axis. Okay, and then we are going to look for the angle that is going to be created with the x-axis by the vector line. Okay, now the 3 here simply means that this line here is also 3, and this is my 90 degrees. If that is the case, then we are going to apply the trig ratios. We have already gone through trigonometry, so you should know how to deal with the trig ratios. Now with the trig ratios, looking at this, we know that this being the 90 degrees makes here hypotenuse, right? This is the angle we are dealing with, so it makes this side the what? The opposite. Then automatically this becomes the adjacent. Okay, that is just a quick reminder of the trig ratios and how to deal with it. Now, since we have the opposite and the adjacent, okay, we have the opposite and adjacent, it means we are going to use what? Twa. Are you getting? So using twa, it means that it's going to become tan alpha equals opposite, which is 3, and then adjacent, which is what? 4. So alpha equals tan inverse of 3 over 4, and then alpha is equal to, point that on the calculator, okay, so we have 36.8698. 8698. Okay, so approximately 37 degrees. Okay, depending on how you're asked to leave it. If you're asked to leave it to the nearest whole number, that's how it's going to be. If you're asked to leave it to 1 decimal place or anything, then you follow what they are telling you to do, or you follow what the question is asking you for. Now that is the alpha, and according to the diagram, you realize that this one here told you I will be representing it as what? Theta. And that is what we are looking for. We are looking for this angle, not this. But this is what we can readily find. So we use that to get this. So we say that theta is equal to what? 90, because you know that the whole of this is 90 degrees. So if the whole of this is 90 degrees, then we can subtract the alpha that we have found. In this case, 37 degrees. When we subtract the 37 degrees from the whole of 90 degrees, we get this one. Okay, because this one is 90. Alright, so 90 minus 37 is equal to theta. So this is going to be 90 minus 37. Then theta is equal to 53 degrees. That is approximately, but it depends on how the question will ask you to leave it. We'll be looking at specific questions and how they are asked to leave it. Okay, but for now, let's handle it that way. Now we are not done. This is just the bearing of it. This is just the bearing of it. So let's move on to the distance. You know, the question is asking to leave it in what? Magnitude bearing form. We have found the bearing. Now let's look for the magnitude. Now with the magnitude, we have already gone through the fact that the formula for magnitude, okay, the formula for magnitude is actually square root of x squared plus y squared. Okay, so that this is going to become, you know, AB to what? 4, 3, and then the x coordinate is 4, then the y coordinate is 3. So that this becomes 16 plus 25, and that is, sorry, 16 plus 9, and that becomes 25, and that is equal to 5 units. Alright, if the question is given in centimeters, it means this is going to be 5 centimeters. If it is given in kilometers, whatever units it's given in, you write it there. But if there's no unit given, you write it as what? 5 units. Alright, now we are writing it in the magnitude bearing form. So then we say, therefore, AB, that is vector AB, is equal to, you know, the distance first, okay? So 5 units. And then the bearing was what? 53 degrees. So 0, 5, 3 degrees. And that is what you have. It's as simple as that. It's as simple as that. Now, let's look at how to deal with this question. I'm going to solve this and I'll give you 2 to try on your own. I've already solved 1. I'm going to solve this one as well. Then I'll give you 2 to try on your own. Express PR, vector PR, equals 5 minus 12 in magnitude all right, so we have PR. It doesn't matter which one you do first, whether the magnitude first or the bearing first. The most important thing is to do all. Alright, so I'm going to start with the magnitude first this time round. So we say that the magnitude of PR is given by x squared y squared. That is square root of x squared y squared. Now this gives you 5 squared plus minus 12 squared. So that this gives you 25 plus 144, and this is going to be 169. Okay, that is equal to 13 units. Now let's look at the magnitude, the bearing part. Now let's represent this on the Cartesian plane. This time round, we realize that the x is on the is going to be on the positive side because it's what? Positive 5. So we have 5 here, but then the y is negative 12. Now the negative is not to be written on the Cartesian plane. It is only giving you the direction to which the y has to go. So then the minus 12 is not going to be written as minus 12, but just what? Positive 12. And then you know that since it is here and here, then the the vector has to be in between both of them with the okay, so with the triangle created with the x-axis, and then we have our alpha. All right, now that we have the alpha, we have here to be 12, we have here to be 5. This simply means that this is also what? 12. So we can get alpha. Alpha now becomes, we know this is our opposite, this adjacent, so we still use what? Twa. For shortcut's sake, always remember that whenever you are dealing with this, you don't need to try any other thing. It is definitely going to be twa, because all the time you are given the adjacent and the opposite. So you are always going to use what? Twa. So we say that tan alpha equals opposite, which is 12, over adjacent, which is 5. So we say that alpha equals tan inverse of 12 over 5, and then alpha equals tan inverse of 12 over 5 is 67.3801. Okay, 67.3801. Then let's say it is approximately 67 degrees. Now with the alpha got as 67 degrees, then we can find the theta, which actually happens to be the bearing. So we can say that theta is equal to 90 plus alpha. Why? Because we have the whole of this to be 90 degrees, and then we have been able to find this angle. So when we combine this angle with the 90 degrees, we can get the whole of that angle. So we can say this is equal to 90 plus 67. So we have 157 degrees as our bearing. And we can say that therefore vector PR is equal to 13 units, comma, and then 157 degrees, and that is it. Okay, so with this understood, I'm going to give you two. Okay, so that is it. Like I said from the beginning, you have this question to write in the magnitude bearing form. You can choose to do the magnitude first or the bearing first. Whichever one you do first doesn't really matter. Now, starting with the magnitude, we have this as the formula: x squared, y squared, all in square root. Okay, so square root of x squared plus y squared, and then you go ahead to get your answer as 13 units. Okay, as I have done there. Then you move on to getting the bearing, and the bearing is this. You first represent this on the Cartesian plane. So that is what we had as the 5 here and then the 12 here. But then this can be projected to this side as the same value. So if this is 5, this is going to be 12. And then from there, we find which particular trig ratios to use. And I told you that all the time it is going to be twa, because you are always going to be given the alpha. Sorry, you are going to be given the opposite and the adjacent to find the angle in the middle, or the angle created by the x-axis, which I have represented as alpha. After you have found the alpha, you just combine it with the 90 degrees, okay, to get the bearing, because in this case the angle is in the second quadrant. Okay, and from where it is, when you combine it with the first quadrant, the whole of the first quadrant, you get the full angle you are looking for. So that is what you have had there. You just combine the bearing you have found and the magnitude to get the magnitude bearing form. So that is it. Okay, so take these two questions as assignments and we are out of here. Okay, so this is the assignment I'm going to leave you with. You have to express all these questions in the magnitude bearing form. So you have CD equals minus 4 minus 11, XY equals minus 3 4, UV equals 6 8, PM, that's vector PM, equals 12 minus 5. So you have to use the magnitude bearing form in representing all the following. Okay, so that's it. All right, so that brings us to the end of today's class. God willing, some other time we'll be continuing. We've been able to complete up to this point. God willing, tomorrow we'll continue and then we'll finish with vectors tomorrow and continue with bearings. Until we meet again, my name is Henry Edem. Bye-bye.